The focus of this lesson is on graphing by transformations. In particular, we're going to focus on reflections this time. So in the rules for reflections are in this blue box here, and there's two types of reflections. There's reflections across the x-axis and reflections across the y-axis. So if you look, basically if you have a reflection across the x-axis, it's when you are applying a negative to your whole function. If you have a reflection across the y-axis, it's when you're applying a negative to just the x's. So I always think opposite letter. If the opposite letter gets a negative, then it tells you the type of reflection you have. So a negative on the y's results in a reflection across the x-axis. A negative on the x's results in a reflection across the y-axis. But you need some insight into what does that actually mean. So since we're graphing by transformations, we're going to start off with our parent function. And in this case, we're dealing with f of x equals the absolute value of x. And then eventually we will perform those two reflections on this function. So you're going to go ahead and graph like you normally do by creating a little t-chart, and then picking some key points that work for the absolute value function. So I know that an absolute value function is a v, so I'm going to pick a negative value. I'm going to pick like its vertex, which is at 0, and I'm going to pick a positive value, so let's say 1. Now, if I apply absolute value to -1, we know that's 1, absolute value of 0 is 0, and the absolute value of 1 is 1. So these are three ordered pairs. So I'm going to go ahead and plot each of these. -1, 1, 0, 0, and 1, 1. So notice that gives me my V shape. So this is my parent function f of x. So I just want to get that drawn. And an absolute value will always be that V shape. Now, if I want to perform my transformations, I have to look at what it says. So g of x is the absolute value of -x. So notice the negative is happening on the x. So this is like your original function, but instead of being evaluated at x, since that negative is happening to the x, we're now evaluating at -x. So the negative is applied to the x's. So that's a reflection across the opposite letter, which is the y's. So reflect across the y-axis. So this is your x-axis, this is your y-axis. If you reflect across the y-axis, that just means your graph needs to flip across the y-axis. So this point here will move here, this point here will move here, and your vertex stays put. So notice it actually overlaps my f of x. So I'm just going to kind of draw in that we're overlapping. So, and that happens if you're dealing with an even function, which is what we're dealing with here. It'll look the same as the original parent function. Now let's look at k of x. K of x is negative absolute value of x. So the negative is applied to your original function absolute value of x. So the negative is being multiplied by your f of x. So there's a negative on the whole function or on the y's. So that means you reflect across the x-axis for k. So whatever your original function in black was, if you reflected across the x-axis, notice the vertex would stay put, but across the x-axis means you're going to be the same distance from the x-axis, just on the other side. So I need to be 1 unit away from the x-axis, need to be 1 unit away. So I get this upside down V if I flip across the x-axis for k. And that's what would happen. So that's the idea behind reflections. So if the negative is happening to the x's, you reflect across the y-axis. If the negative multiplier is happening to the y's, it happens across the x-axis. And all a reflection is just a flip. So all your points just flip across that axis and are the same distance from that axis.